There are things that seem impossible to happen, or rather, impossible on our planet. Because the universe is so immense and so alien to our rules, the impossible happens every day. HD 189733b, the glass shredder. One of the most studied planets outside the solar system is HD 189733b, with a name that sounds like a gift card. It's a gas giant the size of Jupiter that orbits very close to its star, and that makes it a climatic hell. Its day side, which is always the same, reaches temperatures of about 1200 degrees, and its atmosphere is literally made of silicate crystals, the component of glass. At that temperature, silicates remain as vapor suspended in the atmosphere. But the fun part comes now. When they cross over to the much colder night side, they condense. In other words, it starts to rain glass. Drops of glass that form as they cool and fall from the sky like blades. And they don't do it vertically, because this transition between the hot side and the cold side is compounded by another phenomenon: winds of 8,700 kilometers per hour, which, to give you an idea, is 7 times the speed of sound. They are sharp bullets carried by supersonic hurricanes. Obviously, we can cross this crusher off the list of planets to colonize, and that's a shame, because the planet also has an intense blue color like ours. But in this case, it's not because of the water, but because of those glass particles suspended in the air. GJ1214b, the pressure cooker. And if the previous one was a crusher, now we are moving on to a pressure cooker. GJ1214b is 48 light years away and has a dense atmosphere of hydrogen and helium with water vapor and a permanent metallic fog. But forget about open seas. Here, water behaves radically differently. Near the surface, it's vapor, but as it descends, it becomes denser, without becoming liquid. And even deeper down, under brutal pressure, the water eventually solidifies. Not from cold, but from force. This gives rise to a completely alien type of ice called Ice 7. This ice only appears at tens of thousands of atmospheres of pressure and at temperatures above 300 degrees. It doesn't float or melt at 0 degrees. But how is it possible for something so hot to be solid? Because when you squeeze matter hard enough, the atoms rearrange themselves. In this case, the water is so squashed that it can't even move. So even though it's boiling, it solidifies under sheer pressure. The most interesting thing is that this Ice 7 can trap salts and allow nutrients to pass through, making it a possible environment for life. Although you can't see it at the bottom, there could be a whole world down there. Korot 7b, the lava oven. And now we move from the pressure cooker to the oven. Korot 7b is a rocky planet so close to its star that it makes a complete revolution in just 20 hours. So it's obviously quite warm here. Its daytime surface reaches about 2300 degrees Celsius. That not only melts any rock, but it vaporizes it. On that side of the planet, there's no land or ocean, just a constantly boiling sea of lava. But that's not the worst part. What's above isn't an atmosphere like ours, made of nitrogen or oxygen. There, the air is composed of rock vapor, oxygen, sodium, silicon, or aluminum floating in gaseous form, and everything that goes up comes down. At a certain altitude, the atmosphere cools enough to condense these vapors. Just as water clouds form here, clouds of rock form there. Feldspar, quartz, or liquid ruby. And when they become saturated, it begins to rain molten rock, which solidifies as it falls onto seas of lava. It's basically a planet where it rains rock. Titan, a world of methane. But if you think impossible things only happen on very distant planets, don't worry. I have examples from our own neighbors. Titan, Saturn's largest moon, is the only place in the solar system other than Earth where there is rain, rivers, lakes, and seas. But not water. It rains methane there. The temperature is so low, almost minus 180 degrees, that methane and ethane, which are gases here, behave like water there. They condense, flow across the surface, and form lakes. There are coasts, deltas, waves, and even storms. Instead of a hydrological cycle, it's a hydrocarbon cycle. Repsol's dream. And that's not all. It has a fairly dense atmosphere, denser than Mars's. If you walked around there, you'd be wearing a spacesuit, but without fear of it breaking under the pressure. And if you put on wings, with gravity so low and the air so thick, you could fly by flapping your arms. It's one of the few places in the solar system where this would be physically possible. Neptune and Uranus, diamond skies. But don't think our neighbor is strange just because it's a satellite. We also have examples of planets. Neptune and Uranus, two ice giants of the solar system, suffer from something that many would like to see with their own eyes: diamond rain. Not on the surface, of course, but deep within their atmospheres, some 10,000 kilometers deep, where the pressure is so enormous that it crushes molecules. There, compounds like methane, abundant on these planets, decompose. Carbon is released, and instead of remaining loose, it crystallizes in the form of diamonds. Tons of tiny diamonds fall toward the core, like luxurious hail. And then what? Well, when they reach warmer areas, they probably melt, completing a cycle. They form, fall, melt, and start all over again. On Earth, diamonds appear about 150 kilometers underground and take millions of years to emerge. There, they would form every day. It has even been suggested that oceans of liquid diamond could exist around the core. Kepler 16b, the Tatooine of reality. And if you like Star Wars, the planet Kepler 16b will remind you of Tatooine, as it orbits not one, but two stars at once. Even so, it is still a cold, uninhabitable, and gigantic planet. This is what is called a binary system, and although it sounds exotic, it is quite common in the galaxy. The rare thing is for a planet to manage to orbit both stars without becoming completely unstable. But Kepler 16b manages to do just that. It has a stable, almost circular orbit, orbiting the center of mass shared by both. And what does having two suns mean? For starters, the shadows are doubled. The light changes color, direction, and intensity throughout the day. Sometimes there are two sunrises, or one sunrise as the other sun sets, or even a double eclipse. It's a planet where the passage of time feels different, something that would completely disrupt our biological clock. TRES 2b, absolute darkness. But if you prefer dark places, I recommend moving to TRES 2b. As far as we know, it's the darkest object in the universe. It reflects almost no light. Imagine a planet so black that if you flew close, you wouldn't see it. You'd only notice its presence because it blocks out the background stars. TRES 2b is a gas giant the size of Jupiter, but with an albedo of less than 1%. That is, the amount of light it reflects. It is darker than coal, asphalt, or any natural surface we know of. On Earth, we've only achieved something darker by manufacturing it, like Vanta Black, which was designed in a laboratory. And why is that? Its atmosphere seems to be composed of elements like vaporized sodium or titanium oxide that absorb light instead of reflecting it. Of course, appearances are deceiving, since inside it's burning hot. The temperature is so high that it emits infrared radiation. So, although from the outside it looks like a hole in space, inside it actually glows like a burning oven. Io. Volcanic brutality. But let's put some color back into our lives. Io, one of Jupiter's moons, is the most volcanic body we know of. While on Earth there are barely a few dozen active volcanoes at a time, Io's surface is constantly changing. Not because of tectonic plates, but because of the brutality of its interior. And we can blame Jupiter and its other moons. Their gravity stretches and compresses Io relentlessly, as if it were being kneaded by force. This gravitational pull generates so much internal heat that it causes gigantic eruptions around the clock. Some volcanoes, like Loki Patera, a 200-kilometer caldera, spew rivers of lava that travel hundreds of kilometers. And others, like the Tvashtar volcano, have launched columns of sulfur and sulfur dioxide up to 500 kilometers high. To give you an idea, Pinatubo, one of the most powerful volcanoes recorded on Earth, reaches only 40 kilometers. On Io, these volcanic plumes not only pass through the atmosphere, but also exit into space. Some volcanoes do so with such force that they glow at night from orbit. PSRJ 1719-1438b the ultimate diamond. And remember the diamond shower? PSRJ 1719-1438b is not just any planet. It is the collapsed core of an ancient star, converted into a solid sphere of crystalline carbon. But let me translate that for you. It's a giant diamond, 60,000 kilometers in diameter. Not a jewelry-grade one, of course. This is an opaque monster, compressed by gravity, rotating just 600,000 kilometers from its star. A year there lasts just 2 hours. On Earth, the largest diamond ever found weighed 60 grams. Here, we're talking about one that weighs as much as Jupiter. Even adding up all the diamonds in human history, you wouldn't get close to a fraction of this. If this planet could be sold as a conventional diamond, its estimated value would be around 650,000 quintillion euros. Obviously, the market would collapse sooner, but as an astronomical figure, it's insurmountable. Kelt 9b, Cosmic Disintegration.
And things get hot when we talk about Kelt 9b. It's a planet so incredibly hot that it doesn't just melt things, it disintegrates them. Its atmosphere reaches 4,300 degrees, hotter than many dwarf stars. And at that temperature, the air can't hold it. Molecules break apart, atoms separate, and what's left is a soup of loose particles. On Earth, not even molten iron reaches those temperatures. Seen from the outside, it looks like a star that didn't make it. It glows, burns, and its atmosphere slowly escapes into space, disintegrated by radiation. It is, to date, the hottest planet ever discovered. WASP 76b, Iron Rain. And if you thought glass or rock rain was too much, meet WASP 76b, a planet where it rains molten iron. It's a gas giant orbiting so close to its star that a year there lasts less than 2 days. Its day side reaches 2,400 degrees, and at that temperature, iron turns to vapor and mixes with the atmosphere. But when that vaporized iron crosses to the cooler night side, it condenses and falls from the sky in the form of liquid metal droplets, as if it were raining pellets. And it doesn't fall softly. The winds in that band between day and night reach 18,000 kilometers per hour, the highest in the universe we've ever seen. We're talking horizontal rivers of liquid iron blowing at supersonic speeds. For comparison, the fastest wind recorded on Earth was 408 kilometers per hour during Cyclone Olivia in Australia in 1996. That means WASP 76b's winds are 44 times faster than our record. And on top of that, they're trailing a shower of molten metal. J1407b, Lord of the Rings. But if you're into surreal landscapes, you need to check out J1407b. It has a ring system that puts Saturn to shame, as its rings are more than 200 times larger. If this planet were in Saturn's place, its rings would be so large they would fill our own sky. They would even look wider than the full moon. Each of those rings could be tens of millions of kilometers across. And they're not smooth rings. There are gaps, cuts, as if something was shaping them from within, which are likely moons in the midst of formation. If you're afraid of commitment, it's best not to show this planet to your girlfriend. But you could start practicing your commitment levels by subscribing to this channel and obviously activating the bell, don't you think?